In today's webinar, Harvey Goldstein and I will be discussing probabilistic linkage, what it is and what it isn't in relation to the alternative deterministic approaches to record linkage, some issues with the way that it is currently implemented, and some emerging techniques that we think will help us make better use of linked data. We're going to cover two sides of what are really the same coin: the linkage process, in which we make comparisons between records to try and establish whether they relate to the same person or entity, and the analysis step, in which we use linked data to draw inferences about the world. We're going to focus particularly on the issue of how uncertainty in the linkage process is measured and how it can be carried through into analysis of linked data. Uncertainty arises mostly because of overlap in patterns of agreement, which are the main source of information that we have for distinguishing between matches and non-matches. Usually it's the case that for some patterns of agreement, some of the candidate links truly do relate to the same entity and some don't. And no amount of fancy analytics can remove this uncertainty. If we can't remove it, then what we really need to do is measure it. This is where probabilistic linkage comes in. Probabilistic linkage generates a score for every possible pattern of agreement, which provides an indicator of the relative level of uncertainty associated with each. But that score is based on a statistical model, parameters of which may be unknown, and independence assumptions that are routinely violated. While this is not necessarily a problem for what we usually do with these scores, which is simply rank candidate links and select the best, it does mean that match weights cannot be readily converted into adequate estimates of uncertainty, so-called match probabilities. This way that we rank candidate links and discard all but the best, after which we ignore information provided by match weights, reduces probabilistic linkage to being simply a more sophisticated form of deterministic linkage. If we are to make optimal use of linked data, then we need to capture and use information about all of those uncertain links, and ideally do a better job of measuring the uncertainty that they carry. Pretty much all forms of probabilistic linkage are underpinned by the framework that Fellegi and Sunter formalized back in the 60s. We're going to present two alternatives to this that are some of the first to truly break this mold. One is the scaling algorithm published last year by Harvey and colleagues, which takes the algorithm underlying principal component analysis and applies it to the problem of record linkage. This is attractive in that it doesn't require estimation of M and U values. It is always calculable and quite rapidly, and it allows for dependencies between matching variables to be explicitly accommodated. I'm then going to present some forthcoming work that I've been doing on direct estimation of match probabilities as proportions, the proportion of any group of candidate links that truly are matches. This approach reduces the independence assumption to one critical matching variable, but then implicitly accommodates dependencies and missing data on all the rest. It's the first technique that we know of to provide theoretically consistent estimation of match probabilities in unsupervised record linkage. Lastly, we're going to discuss the methods that we've been working on for making better use of information about uncertainty and linkage error. I'll introduce a classification system that allows the impacts of linkage error to be identified and addressed using conventional techniques for quantitative bias analysis. Then Harvey will outline some work that he has done showing how linkage uncertainty can be reflected using techniques borrowed from the missing data toolbox, specifically a form of Bayesian imputation. So I hope that you can join us for this webinar or watch it online later, and we look forward to receiving your comments and questions. Thank you.